Today, first we'll discuss about CloudWatch. Then after we complete CloudWatch, we'll move for another service. Okay. So what is CloudWatch? Nothing but you guys remember yesterday we're discussing about the VPC before the data scaling and load balancing we're discussing, right? In that class, we use CloudWatch to monitoring the resources like alarms, those kind of things. So remember, CloudWatch is a monitoring tool in the AWS, which will allow us to monitor the metrics. Metrics nothing but resources. Cloud resources can be monitored. The health check of the resources can be monitored. Okay. So what type of things can be monitored? CPU, memory, disk, application. Those everything can be monitored using CloudWatch. CloudWatch come up with two options. One is basic monitoring. Another one is detailed monitoring. But I think basic monitoring is free and you don't need to pay any amount, and the values, the data will get every 5 minutes once. The data will update every 5 minutes once. But detailed monitoring is payable. Data will update every 1 minute once, but it's not free. We need to pay the amount for to view the data. But the data is very accurate also, and along with very rapidly you'll get the data the span of 1 minute. Amazon CloudWatch monitors your AWS resources and the application you can run on the AWS in real time. You can use CloudWatch to collect and track the metrics, which are variables you can measure for your resources and applications. The CloudWatch homepage automatically displays the metrics about every AWS service you use. You can additionally create custom dashboards to display metrics about your custom applications and display custom collections of metrics that you choose. You can create alarms that you watch metrics and send notifications or automatically make changes to the resources you are monitoring when a threshold is breached. For an example, you can monitor CPU usage and disk reads and writes of your EC2 instances, and then use this data to determine whether you should launch additional instances to handle the increased load. You can also use this data to stop under used instances to save the money. With CloudWatch, you can gain system-wide visibility into resource utilization, application performance, and operational health also. You can also use CloudWatch using console, CLI, and API SDKs also can be used. We can use CloudWatch events to send an event notification from AWS to AWS Lambda functions, Amazon SNS topics, or streams in Amazon Kinesis, and the other target types also can be used. We can use CloudWatch Logs to monitor, store, and access your log files from the AWS console and AWS EC2 and AWS CloudWatch, CloudTrail, and other resources. As I said, right? We have two types of monitoring set there: basic monitoring and detailed monitoring. Basic monitoring is free to use, and detailed monitoring is chargeable. Generally, if you look at CloudWatch, we have a dashboard. You can create a dashboard based on the services that you want to be monitored, and can create a graph to monitor the service also, like a bar chart. Any type of graph can be created to view the data. Then alarms also there. Alarms, you can create a CloudWatch alarm that watches a single metric, nothing but it can track the information. The alarm performs one or more actions based on the value of the metric relative to a threshold over a number of time periods. The action can be an Amazon EC2 action, or auto scaling action, or a notification sent to an Amazon SNS topic. An alarm has the following possible states: OK state, alarm state, insufficient data state. This is possible states. OK means the metric is within the defined threshold. Alarm means the metric is outside the defined threshold. Insufficient data means the alarm has just started, the metric is not available, or not enough data is available for the metric to determine the alarm state. Okay, these are the possible states available. Billing, you can create alarm to monitor your billing alerts also, and you can send a custom notification when you're billing more than the amount you specified. For example, you define $10. Whenever your bill is above $10 means it will going to notify you. So you are using high consumption rate, so please delete the unused resources. Like this, it will going to send a notification. Then CloudWatch Logs also available. We can use CloudWatch Logs to monitor your infra. You can use CloudWatch Logs to monitor, store, and access your log files from AWS instances, CloudTrail, and Route 53, and other resources. So CloudWatch Logs enables you to customize or centralize the logs from all of your systems like applications and AWS services that you use in a single or highly scalable service. You can then easily view them, search them for specific error codes or patterns, filter them based on the specific fields, or archive them securely for your future analysis. CloudWatch Logs enables you to see all the logs regardless of their source, single and consistent flow of the events decided by the time. What type of logs you can monitor? Monitor the HTTP response codes in Apache logs, receive alarms for errors in kernel logs, count exceptions in application logs. Like this, multiple things can be monitored. Even sometimes events also can be monitored. Then we have a event buses also there, service lens also there, and service lens can monitor infrastructure monitoring and along with the transaction monitoring. Both can be monitored. Then content insights also there. Nothing but CloudWatch content insights can be used to collect, aggregate, summarize the metrics along with your container application microservices also. Like for Kubernetes and Docker also, it can be monitored. Okay. Synthesis is the one of the tool in the CloudWatch. It's used to create canaries, configurable scripts that run and schedule, monitor your endpoints and APIs. Canaries follow the same routes and perform the same actions in a customer, which make it possible you to continuously verify your customer experience even when you don't have any customer traffic on your application. Okay. Let me show that how this CloudWatch will work. So search for CloudWatch. Open link in the new tab. Look at it, guys. This is the CloudWatch console. Okay. This is the dashboard window. Custom dashboards are there, automatic dashboards also there. I just click on automatic dashboards. You can see these are the dashboards you can able to monitor. Under the custom dashboards, we never created any dashboards. We didn't created any dashboards. If at all you want, we can able to create the dashboards. So then we have alarms are there. All alarms also there. Okay. Right now there are no alarms. Okay. So then we have the logs which we discussed, right? Log groups. If I click on, all the logs can be monitored from here. Here we didn't enable any logs. So if you have enabled any logs, it should not show that. Live trial also there. Then log insights, contributor insights. Like this logs you can monitor. Then we have metrics will be there, graphs, all the metrics, all the graphs you can able to monitor, like application, ALB, EBS, EC2 events. Many things can be monitored. Explorer also there, streams also there. Then we have a Xerox X-ray traces there. Events will be there. This will take you to the different window. Event rules that would be. Then apart from that, you can see application signals also their services. Any service is failing, any service is up. Those status also we can able to see. Then network monitoring, for example, flow control, internet monitors, synthetic monitors. Like this, multiple options are there. Okay, so here first what I'm gonna do means I have one server already. Container insights. We're talking about microservices architecture, right? Like a Docker, Kubernetes clusters. Those also can be monitored here. But right now I don't have anything. If something is there, we can monitor it from here. So I'll do one thing. In my AWS console, I'll start this server. For this server, I'm gonna show that how this CloudWatch will work. So guys, look at there is a symbol called what is that alarm. Alarm status is there, correct? So view is here. So right now I didn't enable any alarms for this. So now what I'm gonna do means I have a plus symbol will be there here, correct? Alarm status, view alarm, then after that plus symbol will be there. Click on plus symbol. So I'm going to create alarm. Now I'm gonna create the alarm. I'm gonna show that how alarm will work for this particular server. Okay, how it will monitor, how it will going to taken care about the things. So those I'm gonna show that. Create alarm. Here we can give the alarm notification. Already I created the same thing I can give. Then alarm actions are important. Enable the actions. So for example, uh, whenever 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 CPU of the server increased, then what you need to do? So we can recover the instance, reboot the instance, stop the instance, terminate the instance. I'll choose stop. So that means if suppose like more CPU is there, alarm is raised, means what will happen means your server will going to stop automatically. That's for the functionality. You don't need to stop. Server automatically will stop. But then who will stop? CloudWatch will stop. Okay, that's about this. Then here average greater than maximum will take. CPU utilization only I'll take. Greater than or equal to 0.99 is there. I'll put 1%. If generally people keep 80 or 90%, but we don't have any data, right? That's the reason only 1% I kept. If suppose CPU utilization of this particular server is one by one means 1% means it automatically stop the server. Okay, so then right now how much is that is not reflecting here. It's okay. We can create. Now what will happen means, guys, now if I refresh it here, CloudWatch all alarms, here it should reflect the changes. See, AWS EC2 the server, so insufficient data state is there. So today and CPU utilization also mentioned here. So the range we given here, correct? So now it's showing that warn or something, warning. Sends a message to SNS, the topic with endpoint is pending. It will not work as expected until the endpoint is confirmed. Look at the subscription confirmation with the setting. Okay, no problem. Look at guys, it's in alarm. What's happening here? Let me refresh. The server might be stopped. When alarm is raised, look at stopped. I started, but it stopped. Why it stopped? Monitoring. The first graph I'll see. If suppose above 1% means it might be stopped. Where is that box? Last 1 hour or 3 hour. It's not reflecting. Look at guys, here is the box. Here is there. So 5%. Above 1% itself it will gonna raise the alarm, but it's already 5% is there. That's the reason server we kept in a stop state. Server is stopped automatically. Okay. How it was stopped? Because of the CloudWatch alarm. Because of the CloudWatch alarm. So now it's stopped, right? After a while it will going to clear up. And the state in alarm is there, it become normal. Okay, I'm gonna delete this one, not required for me. Actions, delete. Like this, the CloudWatch will work. Any question, guys?
So nowadays they have coined up a new word like observability. Is it same like cloud monitoring or something different? Cloud watch monitoring.
It is DevOps monitoring. That's a different world. But even the people are there at SRE, site reliability engineer, DevOps engineer. Those guys also monitor the logs from the AWS CloudWatch only. We do have third-party tools also, but those tools also we're going to learn as part of the course in the DevOps, like Grafana and Prometheus, Shinken, Nagios, then Splunk. Like this, some tools we're going to learn, but there I'll explain that how it works.
But this one is same as observability, no sir? Same thing, no?
Observability. Same only. Observability, monitoring, those are same only.
Okay.
Okay. That's
Which
about
one
the
is a popular monitoring tool, sir? Outside the
uh,
CloudWatch?
Prometheus and Grafana.
Okay.
Okay. Any questions, guys? Any other questions?
So on day-to-day activity, we are not monitoring. No, DevOps engineers are not monitoring the monitor this part. No, so usually there will be separate team for this one. They will keep on monitoring. If something goes wrong with any of our servers, they will inform us. Correct? No.
Correct, correct. Like we used to get an email ourselves also. Some companies they have a dedicated team called a monitoring team, knock team will be there. Those guys used to report us like this functionality is not working, that functionality is not working. They used to inform us. So we need to log into the server and we can verify that what was the problem.
Okay. Okay.
Like this, we can able to monitor. Glacier CLI we discussed about. CloudFront also we know about the CloudFront. EFS we need to discuss about that EFS. EFS required a servers. EFS required two servers. Okay, we'll try to do this. What is EFS? EFS is nothing but elastic file system. EFS is nothing but elastic file system. Kind of a storage. Amazon EFS elastic file system ಅಥವಾ Amazon EFS provides simple scalable file storage for use with Amazon EC2. With Amazon EFS, storage capacity is elastic, growing and shrinking automatically as you add and remove the files. So your application has have the storage when they need it, when they have required. Amazon EFS supports the network file system. NFS version 4 and NFS 4.0, 4.1 protocol should be used. So the applications and the tools that you use today work seamlessly with Amazon EFS. So multiple Amazon EC2 instances can access your Amazon EFS file system at the same time. Okay, means multiple people can able to access the data. Assume that. Proceeding for a providing a common data source for workloads and applications running on more than one instance for the server. So EFS with Amazon EFS, you pay for only storage used by your file system, and there is no minimum fees or setup cost. Around the cost related to provision throughput are determined by the throughput values you specify. Amazon EFS file system store data and metadata across multiple availability zones in a AWS region. EFS file systems can grow up to petabyte scale, drive high levels of throughput, and follow massively parallel access from Amazon EC2 instances to your data. Okay, how to install this one? Sudo yum install -y Amazon EFS install. We can use this command to install the things. Okay, then post that we can answer this Q and question and answer things. So right now, what is required means I'm gonna do like this. So I required two servers. I'm going to create two servers. Launch instance. I'll give the name called EFS. Then Amazon Linux. Amazon Linux 2 AMI I'll take. You guys also can take the same thing. Keeper already there, the existing keeper I'll use. So here, these are common. Select an existing security group. Already security group is there. I'll choose Ansible security group. Size is also fine. Details under this. I have to add a script here. One script is there. I have to add the script. Let me fetch the script first. Write down the script here only straight away. Bin bash number of instances 2 I'll need to keep. Servers are created. Okay, now we need to search for EFS. You can go to EFS. Create file system. Customize. Here I can give the file system is my EFS. Regional one zone is a regional. Backup is not required for me. Lifecycle management also not required. So then come little bit down. Enhanced elastic. Then we have next. Network is important. I can select default. Then where my servers are created, I need to look into that here. So available zones we can check. 2A is there. So only can select 2A, but the remaining can be deleted. 2A is selected. Security group also we need to choose Ansible. This is a security group I use for my servers. Select that. Next. Nothing is required. Next. I can click on create. Here it will going to create. But before that, I want to log into the servers. I can name it like this: EFS-1 and EFS-2. Connect. Disconnect. This I'll connect both the servers. Let me verify EFS is created or not. Okay, folder is created. EFS folder is created. Okay, now what I can do means this EFS window, we have attach symbol is attached. This link you can copy and we can go back here. First, let me show the df-h not mounted in both the servers, not mounted. So now what we'll do means, so we can paste this value and last EFS is there. We can put /EFS. If it's all good, yes, resolve. Okay, what happened to this one? So progress NFS. Now mounted. Now run the df-h command. See, last mounted is there. Here also two different servers, df-h. Here also mounted. What I need to do that means now. So look at guys, One is 142 server, another one is 151 server. Both are different servers. In one server, I'll get in cd space slash EFS. I'll go. If I create some files here, like echo files in EFS 2 server, EFS-2.
Sir, will you type clear so that you can view that on the top of the terminal? We are not able to view that. It went bottom of the terminal.
Let me copy this data first.
Okay.
So that you guys will get to know what I'm doing exactly. Will it be fine?
Yeah, sir. Yeah. Now it's visible, sir.
Remember, guys, I created this file. Look at, I created this file which server? EFS2. Correct. Now I'm moving to the EFS1 server, cd space slash EFS. Now the files what I created there, second server. Now I'm in first server. Here also the same file should be appear. See, if I create files here, it will appear there as well. Total 3 files are there, correct here. Let me go to the server 2. Let me do LL. 3 servers are this EFS1. That means the use of the EFS will be synchronizing. So nothing but in one server, if you update, it will automatically update on another server. Not only other server, like how many servers you will going to do as a part of EFS, right? Those all will be shown the same output. Okay, but if you create the files in different folder, it won't be. If you mount which folder we mounted, df-h, that only be work. See, if I mounted to slash EFS, correct? In this folder, whatever you create, this will be synchronized with all the servers. All the servers means wherever you mounted this EFS, right? In all the folders. It's kind of a centralized storage, you can think. And why it's reflecting 8E here? Extended. E nothing but extended, nothing but 8 GB, 9 GB, any GB can be stored there, because this won't store data in your local laptop. I mean, not in the server. It will be stored on the EFS cloud. In the AWS EFS cloud is there. From there, it will go into store. Clear?
A kind of sharing in Linux, no, sir? Something.
Share drive, we can assume that. In Linux, there is a concept called NFS, will be the network file system. Same
Yes,
way.
yes, yes, yes.
Okay.
It's more expensive, no, sir, mostly?
Not
EFS.
so expensive, but it's manageable.
In your company, are you using this one, sir?
In my company, we're not using.
Okay.
Based upon the requirement,
Yeah. Correct.
they'll use this. But in my company, there is no requirement of using EFS. We're not using, but we need to aware about the topic.
Correct.
This is kind of, you can treat like a shared drive, sharing the data between the two systems.
Yes. Sharing the drive. Yeah. NFS.
Yeah, that's the use of this EFS. Look at what is EFS means, elastic file system. What do you have to remember when working with EFS and EC2? We have to remember security group and VPC, and along with the server capacity. How much does EFS cost? EFS, we have some cost will be there. How many instances can I mount to EFS? Many instances, unlimited you can mount. How much data can store in EFS? There is a limitation. Any data, how much data you want, that much data you can keep. Okay, there is no limitation of the data. Okay. That's what about the EFS part.
But sir, as a data grows, it will be charged, no, sir, in EFS.
Yeah, definitely. Even 1 GB if you're storing also, it will be chargeable.
Correct. Okay.
Whatever the value you're gonna keep, right, that much cost you need to pay. If you're
Correct.
storing 10 GB, if you're storing 15 GB, you need to pay that much amount.
Okay.
Okay. So we need to stop this to terminate this servers. The servers not required for me. I'll delete this server EFS1 and EFS2. If required in future, we can create. And the EFS which we created, that also we need to be removed. So if we can come here, close this window, then we have a delete option. Is there? Click on delete. Here we need to give the this value. FS value is there, right? That we need to copy paste and we can confirm to delete. It's deleting. It'll take
So
some
will you
time.
give the examples where this EFS is used in industry usually, like where in where whether in Netflix or ESPN, where it is used usually, sir?
Use right for centralized data sharing NFS Linux systems.
Okay.
NFS we need to set up in your Linux machines, right? Setup is
Correct.
difficult.
Yeah, it's challenging in local, and I come across these things in non-cloud. Non whenever we had this one, no sir,
In cloud
our
also, if I have a 10 Linux servers there means, so if at all I want to configure NFS in 10 servers means quite difficult for me. Lot of steps will be there.
yes.
Yeah, NFS is network file system. EFS is nothing but elastic file system. NFS, EFS both are same only. You think like that. NFS you need to manage everything, but EFS everything managed by cloud. You just need to mount it. That's it.
Yeah, install that respective package and mount it. That's it.
Exactly. That's what this EFS can do for us. I removed that EFS also, and along with the servers also I removed. Virtual product cloud we discussed about that. Next we have small storage gateway will be there. This is theoretical one will be there. No practical for this. This one and another one will conclude that as well. Storage gateway. Remember guys, name itself is the storage gateway, nothing but storing the data. Storing the data. Like where this service will be used means this service mainly used in the database migration. I mean, not only database migration, server migration. If at all migrating some data, then that place this storage gateway can be used. AWS Storage Gateway connects an on-premises software appliance with cloud-based storage to provide seamless integration with the data security features between your on-premises and IT environment and other AWS storage infrastructure. You can use AWS service to store data in AWS cloud for a scalable and cost-effective that helps to maintain the data security very commonly. So AWS Storage Gateway offers file-based storage, volume-based storage, and tape-based storage. These are the three types. Remember, guys, volume-based storage, tape-based storage, and along with file-based storage. AWS Storage Gateway is a hybrid cloud storage. Means hybrid cloud nothing but in a local laptop also you can store. I mean, physical server and along with cloud server both can be interactable. That is hybrid service that gives you on-premises access to virtual unlimited cloud storage. Customers use storage gateway to simplify the storage management and reduce the cost for key hybrid cloud storage use cases. So this include moving the backups to a cloud using on-premises files shares backed by a cloud storage and providing low latency access to the data in the AWS for a on-premise application. AWS Storage Gateway software appliance is available for download as a virtual machines. Image that you can install on a host on your data center. Storage Gateway supports either VMware XRC or Microsoft Hypervisor V. Once you have installed this gateway and associated with your AWS account through the activation process, you can use the AWS management console to create the storage gateway option that is right fit for you. This is the three types will be this. File gateway will use for NFS. Volume gateway will use for ISCSA. Internet Small Computer System Interface we call it as ISCSA. Volume gateway having again two storage classes. One is stored volumes, another one is cached volumes. Then the last one is VTL, virtual tape library, or tape gateway. This is the types are available in the storage gateway. Let's will explore one by one. What is file gateway? What is the use of file gateway? How much data we can migrate from file gateway? Those things we'll discuss. File gateway nothing but files are stored as a objects in your S3 buckets and access through network file system NFS file can be used. So ownership permissions and timestamps are durably stored in the S3 bucket in the user metadata section of the object stored associated with the file. Once object is transferred to S3, they can be managed native cloud object and bucket policies such as versioning, lifecycle management, and cross-region replication apply directly to the storage store object stored in the cloud bucket. Look at guys. This is the application server will be there in the on-premises. You installed storage gateway software from Linux. So then using AWS cloud, it will going to be uploaded this particular all the images and all the data to S3 bucket. This is the S3 bucket, see, right side. Then we have volume gateway. Volume gateway interface represents your application with disk volumes using ISCSI.
Sir, will you go to that previous slide, please? I want to go to that this one, that picture. Yeah, yeah.
You can see here NFS SMB, two options are there. NFS is nothing but network file system. This application server also Linux, this storage gateway also Linux. Then NFS will be used. If application server is Windows, storage gateway is Linux, then SMB can be used. SMB means Samba.
Yeah, yeah, correct.
Okay. Then how it will connect? Either AWS direct connect can be used, internet can be used, VPC also can be used to transfer the data. So how it will connect to AWS account via using S3 bucket? Like we guys are aware about it. In your local laptop command prompt, we created a S3 bucket using CLI. AWS S3 MB like that we used. Same concept works here. We can configure CLI and we can able to communicate. Whatever the data will be there in the on-premises servers, that will automatically copy to the cloud S3 bucket.
It's a kind of hybrid, no, sir?
It's a hybrid. That's what they mentioned here, right? Hybrid cloud. This is the hybrid cloud version. That means your data center data will be copied to cloud. That's a migration we are calling it as, right? Migration we are doing.
For that, its storage gateway will facilitate between these two.
These two, on-premises and along with S3 bucket. If it's a data, like we might be available SAN storage, NAS storage, right? Heavy data.
Yeah. Yeah.
Those can be copied using this NFS via storage gateway. Okay. In case your data is like a servers, not a raw data, it's a server data. Then the volume interface represents your application with the disk volumes using the ICSA block. So data returned to these volumes can be asynchronously backed up as a point-in-time snapshots in your volumes and stored in the cloud as a Amazon EBS snapshots. Snapshots are incremental backups that capture only changes blocks. All the snapshot storage is also compressed to minimize the your storage class charges also. There are two types of volume gateways are there. This is the one. Stored volume and it is cached volume. Stored volume and cached volume. What is stored volume? Stored volumes let you store your primary data locally. Locally means on-premises. And while asynchronously backup the data to AWS also, S3 bucket. Stored volumes provide your on-premises application with low latency access to their entire data sets while providing durable offline backups. You can create storage volumes and mount them as ICSC devices from your on-premises application servers. Data returned to this stored volume is stored on our on-prem storage hardware. This data is asynchronously backed up to Amazon S3 in the form of Amazon EBS snapshots. The size of the stored volume is 1 GB to 16 GB. Maximum how much we can data stored means in the stored volume 16 GB, 16 TB is the maximum. So look at end users use their laptop. This is the data center. Remember guys, this is the data center. This is a server. This is a SAN storage will be here. And this everything will be backed up to AWS S3 as a snapshots. That is a stored volume. We have cached volumes also there. So let's you use Amazon S3 as this primary data storage while returning frequently accessed data locally in your storage gateway. Cached volumes minimize the need to scale your on-premise storage infrastructure while still providing your application with low latency access to other frequently accessed data. So you can create storage volumes up to 32 TB. So earlier, one 16 or like 1 GB to 16 GB, 16 terabytes only storing. But here it comes 32 TB we can store where cached volumes. Last one we have a tape gateway. So like a tape gateway, nothing but earlier you guys aware about there are no movie theaters. There is no multiplex also, there is no PVR IMAX also not there. What was there? Tent. Tents are there. You guys recall about that? Very olden days. If at all you want to watch the movie where you are going, so tents you will wants to go and tent via using reel, movie reel. So they could able to show the movie, correct? They update the movie. So that reel you guys saw that black color one, that reel we called
Yes,
is
sir.
a tape.
Yes, yeah, yeah, yeah. We do remember about that.
The movie size is around 4 GB, 5 GB is there, means what people will do, they'll update it to that particular tape and they used to play from there. Okay, that is a tape storage. Nothing but data can be stored in the tape as well. That is a disk tape gateway. Offers a durable, cost-effective solution to archive your data in the AWS cloud. The VTL interface is provides lets you leverage existing tape-based backup application infrastructure to ensure data in a virtual tape cartridges that you can create your own tape gateway. Each tape gateway is pre-configured with a media changer and tape drives, so which are available to your existing client backup application as a device. You add tape cartridges as you need to archive your data, supported by net backup, backup exec, vname, etc. Like this, tape gateways can be used and we can able to store the data in the AWS cloud. It is like a file gateway for part files stored directly to S3 bucket. File gateway will be used to store the data directly in the S3 bucket. But volume gateway under the stored volumes will be used to entire data is stored in the on-site and is asynchronously back up to S3 bucket also. Cached volumes, entire data set is stored in S3 bucket and the most frequently accessed data only will be kept on the site. Then gateway GVTL, Gateway Virtual Tape Library, used for backup and uses popular backup applications like Net Backup, Backup, EXSC, Vim are the tools we can able to use to store the backups. Okay, that's about the storage gateway. Now you guys understood why do we need the storage gateway? That is for migration purpose only we require the storage gateway. Clear? Any questions? Next, very small topic. If at all you want to do a migration, remember guys, if at all you guys has to do the migration, like entire data center in your company, whatever the data is there, right? Entire data you want to move to cloud. With the normal internet speed, you cannot able to do that. If at all I want to store entire data in the AWS cloud, how do I store? For that we are called as Snow family. Snow family having three devices. Okay, so the three devices nothing but snow cone, snowball, snow mobile. These are three devices. Snow cone, snow mobile, snowball, like this. Applications are moving to the cloud faster today than ever before. A new category of application requires increased capabilities, performance at the edge of the cloud or even behind the edge of the network also. AWS provides the edge of infrastructure and software that moves data processing analysis as close as necessary to where the data is created in order to deliver intelligent real-time responsiveness and streamline the amount of data transferred. The AWS Snow family helps the customers that need to run operations in a Aster non data center environments and in locations where there is a lack of consistent network connectivity. AWS Snow family comprised of AWS that is Snow Cone, Snowball, and Snow Mobile devices offers a number of physical devices and capacity points, most with the built-in computing capabilities. The AWS service help physically support up to exabytes of data into in and out of the AWS. Means terabytes and exabytes of the data can be transferred. Okay, AWS Snow Cone. This is a very smallest device in the AWS Snow family. Edge computing and data transfer devices. Snowcone is portable and rugged and long secure also. This device is very small and we can able to carry this device to any place. You can use cone to collect and process and move the data to AWS. either offline by shipping the device back to snow cone is a device, guys. Remember, it looks like a normal notebook or maybe a suitcase kind of thing will be there. You need to order this device from the AWS Amazon. If you order it from the Amazon will going to send this device to you physically. Okay. For this device, you don't have to pay any amount, but you're gonna do the data migration to AWS, right? Then you need to pay for that. Where we can able to use this snow cone, running applications in disconnected environments and connected edge locations can be challenging because these locations are the lack of space, power consumption, cooling needed for the data center IT equipment. Then snow cone stored data securely in edge locations and can run the edge computing workloads that AWS IoT Greengrass or AWS Amazon EC2 instances. Snow cone devices are small and weight of 2.1 kg, so you can carry one if a backpack or fit it in the tight spaces for IoT, vehicular, or even drone use also can be used. The device looks like this, guys. You can see it in the diagram, right? This is the snow cone. Then we have next one, snowball will be there. Snow cone is very small one, so we cannot store much data. Max to max 2 TB to 4 TB you can store. That's it. If at all, if you want to do a data migration more than two like maybe 50 60 80 90 TB, like that means, then snowcone is not supportable. We need to go for snowball. Snowball is a data migration and edge computing device that comes into two device options: compute optimizer and storage optimizer. These are two options are there. Compute like snowball edge storage optimizer device provide 40 virtual CPUs of compute capacity and coupled with 80 terabytes of usable block or Amazon S3 storage. It is well suited for local storage and large scale data transfer. So, Snowball Edge Compute Optimizer devices provide 52 virtual CPUs and 42 terabytes of usable block storage. Okay. So this is a suitcase. Customers can use these two options for data collection, machine learning, and processing and storage in the environments with intermittent connectivity, such as manufacturing, industrial, and transportation, or in extremely remote locations such as military or maritime operations before shipping it back to the AWS. This device can also be rack mounted and clustered together in the very large, build larger and temporary installations also can be used. Last device is Snowmobile. Snowmobile is like a truck. AWS Snowmobile moves up to 100 petabytes of data in the 45-foot rugged container and is ideal for multi-petabyte or exabyte data scale migration and set data center shutdowns. A Snowmobile arrives at the customer site and connected to the network attached storage in the company, and its data transfer also will happen. After data is transferred to Snowmobile, it is driven back to AWS region where data is isolated to the Amazon S3. Look at guys, this is a truck. Snowmobile is a tamper resistant, waterproof, and temperature controlled with multiple layers of physical, logical security, including the encryption, file suppression, dedicated security personnel, GPS tracking, alarming, camera, 24% video surveillance, and escort vehicle during the transit. Nothing but if you are moving this vehicle right in the on the road, in the before the in front of this one there could be escort security vehicle will be there going on. Okay, because data is very crucial, right? If suppose somebody is hijacked your this particular mobile device and if they copied the data means everything we're going to lose, right? Because entire project data and entire complete data will be stored in this particular paths only. Okay, that's about the storage Snow family, storage gateway Snow family, CloudWatch, and along with EFS. This is the four services we discussed today. Let me know if any questions or confusions, guys. If nothing, we'll disconnect and next class we'll discuss about cloud formation template. Thank you.